Okay, 8.5 word problems for mutually exclusive events. So we're still going to be using the idea of the formula that I have written. Probability of A or B is probability of A plus probability of B minus probability A and B. Right, and I talked about the Venn diagram the other day about how we have to subtract out the double counted stuff. And I think that'll make a little bit more sense today. So, number one, a litter of kittens consists of 2 gray females, 1 gray male, 3 black females, and 1 black male. Right? And I'm just putting that out there so that it'll be easier in a minute whenever we have to do the problem. You randomly pick one kitten. The kitten is black or male. So we want to find the probability of black or male. That's going to be the probability of black plus probability male minus probability of black and male. Okay. And I didn't read the directions, but we're supposed to determine if the scenario involves mutually exclusive events. So really what we're asking here is this possible? Can you have a black male? And we look right there, and yes, you can have a black male. So this is not mutually exclusive. Okay. So now we start writing in. Probability of black. Well, how many total do we have? We have 3, 4, 5, 6, 7. We have 7 total. So the denominators are all going to be 7. How many black kittens do we have? We have 3, 4. We have 4 total black kittens, right? I added this one and that one together. And then we want male, so I'll add this one and this one together, so we have 2. And then I've already said that black and male, we only have 1. So I add those up, and I'm going to have 5 over 7. And that's our answer. And we can kind of think about that the reason that we had to subtract this guy out is because he was the black male kitten, and the black male kitten fell into the black category and the male category. So he was double counted. So we had to take out his double counting. And then we ended up getting 5/7. So hopefully that makes sense, but let's do a few more. Number 2, a box of chocolates contains 5 milk, 5 milk, and 6 dark. One of the milk chocolates and 5 of the dark chocolates has peanuts. So like 1 milk peanut and 5 dark peanuts. You randomly select and eat a chocolate. It is a milk chocolate or has peanuts inside. So we want probability of milk or peanuts. So how many milk chocolates do we have? Well, how many total do we have? We have 11. Remember, it's worded a little bit different than the last one. This counts all of them, and this is just a special piece of the ones that we have. Right? Did I read that right? 5 milk chocolates. Yes. So like last time, we had 4 completely separate categories that they gave us. Right? This one here, we have 2 categories, and then we have like subcategories, right? So don't count them all together. So total we have 11. So my denominators will be 11. Probability of milk will be 5. Probability of peanuts will be 6. And then how many milk chocolate, peanut chocolates? I have 1. So I add those up and I'll have 10 over 11. And I don't think I answered the question, is it, no, I did not. So is this mutually exclusive? And again, the question is this guy equal to 0? Well, obviously it's not, so this is not mutually exclusive. All right, moving on. Number 3, a basket contains 7 apples and 5 peaches. So 7 apples, 5 peaches. 2 of the apples and 2 of the peaches are rotten. So 2 rotten apples, 2 rotten peaches. And just like in the last one, these are kind of like subcategories. You randomly pick a piece of fruit. It is fresh or it is an apple. So I'm going to write down here, we have it listed as rotten, but let's write the fresh. So we have 5 fresh apples and 3 fresh peaches, right? I took my 7 minus 2 to get 5, and then 5 minus 2 to get 3. All right, what am I supposed to find? You randomly pick a piece of fruit. It is fresh or an apple. So probability fresh or apple will be the probability of fresh plus probability of apple minus probability of fresh and apple. Now, mutually exclusive, yes or no? And again, we're talking about, is this equal to 0? Well, fresh apples, we have 5 fresh apples, so this is not mutually exclusive. All right, how many total pieces of fruit do we have? We have 7, and then 5 gives me 12, so all these have a denominator of 12. Fresh fruits, we have 5, 6, 7, 8 fresh fruits. And how many apples? We have 7 apples. And then how many fresh apples do we have? We have 5. So this is going to be 8, 9, 10 twelfths. Is that right? 10 twelfths? Yes. 10 over 12, which is 5 over 6. And there we are. Number 4, another box of chocolates contains 3 milk, 4 dark, and 4 white. You randomly select a chocolate. It is a milk chocolate or a dark chocolate. So we want to find probability of milk or dark. That's going to be the probability of milk plus probability of dark minus probability of milk and dark. All right, mutually exclusive. Is this equal to 0? Do we have a chocolate that is milk and dark? And the answer is no, we do not. So this is mutually exclusive. So this guy here is equal to 0. Okay, just this piece. All right, how many total do we have? 8, 9, 10, 11. So we have 11, 11, and I'm just going to do those first two because the other one's 0. Or I'll even write that. Milk chocolates, we have 3. Dark chocolates, we have 4. So 4, 5, 6, 7. So we have 7 over 11. And we're done. Number 5, you roll a fair 6-sided die. The die shows a 1 or a 3. All right, it should be pretty easy to see that these are going to be mutually exclusive because you can't roll the die and get a 1 and a 3 at the same time. And I could write out the formula here, but I think it would be just easier to say, well, what is the probability of getting a 1 or a 3 on a die? We've done that a few times before. There's 2 ways to be successful there out of 6, which will be 1/3. Oops, not 1 out of 13, 1/3. Just like that. You could write it out, and it would be 1/6 plus 1/6 minus 0. So there we are, number 6. You roll a fair 6-sided die. The die shows an odd number or a number greater than 4. So probability of odd, or I'll say greater than 4. All right, mutually exclusive. Oh, did I answer that for the last one? Yes, I did. Is there an odd number that is bigger than 4 that's on a die? Yeah, 5 would count as that. So this is not mutually exclusive. So how many odd numbers are there on a die? There are 3. How many numbers are bigger than 4 on a die? Well, bigger than, it's not equal to, so it's going to be 5 or 6. There'll be 2. And then odd numbers that are bigger than 4 will be 1. So 3, 4, 5, 4. So 4 over 6, which is 2/3. All right. Number 7. A box of chocolates contains 6 milk chocolates and 7 dark chocolates. 3 of the milk chocolates and 4 of the dark chocolates have peanuts inside. You randomly select. We've done one like this. I'm just going to skip over that. Number 8. There are 5 nickels and 7 dimes in your pocket. 1 of the nickels and 2 of the dimes are Canadian. Okay, so we have 5 nickels and 7 dimes. 1 nickel is Canadian, so 1 nickel Canadian. And 2 dimes Canadian. 2 dimes Canadian. The others are US currency. You randomly select a coin from your pocket. It is a dime or Canadian currency. So we want to find probability of dime plus probability of Canadian minus probability of dime and Canadian. I skipped over writing that left part here. You're welcome to, or you can write it in there. So are these mutually exclusive? No, because there is a Canadian dime, so these are not mutually exclusive. Probability of a dime. Well, let's count. We have 5 and 7 gives me 12. How many dimes do we have? We have 7 total dimes. How many Canadian? We have 3 total Canadian currencies, or current coins. And then dimes that are Canadian, we have 2. So we have to subtract out the double counted. So this will end up giving me 8 out of 12, which is 4 out of 6, which is 3 out of, no, this is 2 out of 3. 2 out of 3. All right, I believe we've gone over all of the unique problems. Let me just read over these real quick. We haven't done a marble problem yet. A bag contains 3 red marbles, 3 blue marbles, and 5 yellow. You randomly pick a marble. The marble is red or blue. Well, this is going to be mutually exclusive. Right, because there's not a red and blue marble. So we're really trying to find the probability of red plus probability of blue, right? We could write the subtraction piece out there, but we know it's going to be 0, so we can just leave that off. How many total do we have? We have 3, 6, and 5 gives me 11. Red marbles, we have 3. Blue marbles, we have 3. So this is going to be 6 out of 11. We haven't done a sports drink one yet. We have 11 bottles total, 3 lemon lime, 5 orange, 3 fruit punch. You randomly grab a bottle. It is lemon lime or orange. Well, this will be mutually exclusive because they're not mixing up their sodas. We have 11 total, so our denominator will be 11. We want lemon lime. How many lemon lime? We have 3 lemon lime. And how many orange? We have 5 orange. So 5, 6, 7, 8 out of 11. And we'll do number 13 because that's different too. A bag contains 4 yellow tickets numbered 1 to 4. The bag also contains 5 green tickets numbered 1 to 5. That's interesting. You randomly grab a ticket. It is green or has an odd number. All right, so these are not going to be mutually exclusive. Okay. How many total do we have? We have 4 of those and 5 of those, so it's going to be 9. We have 5 green tickets, and then how many odds do we have? Now, of these 4, we have 1, 2, 3, 4. Then the 5 has 1, 2, 3, 4, 5. So odd numbers, I'm just going to count them. We have 2 for the first one and 3 for the second one, so that's going to be 5. And then green and odd, we had 3 green odd ones there. So this will give me 7 out of 9. That's kind of interesting. I don't remember that problem. All right, another chocolate problem. Jerseys, we'll do that one. They're numbered also. A bag contains 6 white jerseys numbered 1 to 6. The bag also contains six red jerseys numbers 1 to 6. You randomly pick a jersey, it is white or has an even number. So this is going to be not mutually exclusive. All right, did I write that for the last one? Yes, I did. All right, we want white or even, so probability of white plus probability of even minus probability of white and even. I like this one because it's 6 and 6, so I know the odds and evens are split up in half. Total, we have 12. We have 6 white, and then we would also have 6 evens, right? 3 from each. And then we have 3 white even numbers. So this will be 9 out of 12, which is 3 out of 4. All right. And we've already done one a whole lot like 16. If you need more help, if you need me to do these other problems, shoot me an email and I'll do that. All right. Bye-bye.